So we're going to do a binomial times a trinomial. So FOIL doesn't work anymore for this, because FOIL, the fact that there's 4 letters is because there's 4 terms. If you look at this one, we have 2 terms times 3 terms. So how many terms do you think we'll end up with?
5.
2 times 3?
Oh, 6.
6. So this one's going to end up with 6 terms when we're done. So FOIL doesn't work because there's not enough letters in FOIL.
You could do foiled.
Foiled.
Foiled. Yeah, foiled again.
So there should be 6 terms when we're done multiplying. So yeah, so we're going to kind of do like a modified foiled. Yeah, we can add ed to that. The ed doesn't really stand for anything, it just sounds better than. So if you stay organized, this way works pretty well. I will show you guys another method that I call the rectangular method, not a really fancy name because it looks like a rectangle. But I'll show you guys that method as well. You might like that for this one. So the modified FOIL is basically, I can't really use the letters all that well. I can use FOIL, or the F, sorry. So I'm going to do the first terms together. So 3a times a squared. But basically this 3a has to be multiplied to all 3 of these. So rather than having 2 arrows coming out of it, I'm going to have 3. So I'm going to do all 3 terms there. And so we have to stay really organized. So 3a times a squared is going to be 3a to the 3rd. Then I'm going to do 3a times a negative 5a. So it's negative, yeah. Then I'm going to do the, like basically the outer ones, so 3a times 1 is going to be just 3a. So I did that first term times all 3, that's how I ended up with 3 terms.
This is a lot easier than I thought it was.
Oh, good. I'm glad that you're not saying like I'm ready to give up. Okay. So,
No, we don't like it.
well, I mean, even if you want to give up, it's sorry. This is what we're learning. What do we still need to multiply? What's been left out? That 4. That 4 needs to go everywhere. So now this 4 has to multiply to all of those terms. Basically, everybody is like kind of meeting everybody in the other parenthesis. So 4a times, or 4 times a squared is 4a squared. 4 times a negative 5a is a negative 20a. And then 4 times 1 is 4.
Are you sure?
I am.
You're 100% sure.
Okay. Now I'm ready to combine my like terms. So right now, notice I have 6 terms. We're going to combine some things that are not going to be 6 anymore. But again, I want to do standard form right away. So my highest power is at 3a to the 3rd. So I'm just going to start with that. That doesn't have any like terms. My next one is the a squareds. So I have negative 15a squared and 4a squared. That's a negative 11a squared. Then I have this positive 3a and this negative 20a. 3 minus 20 is negative 17a. And then the plus 4 is just going to come down on the end. All right, I do want to show you guys the other method because if this is a little bit of a struggle for you, I just want to show you guys the other way and you can decide if you ever want to use it again. It's up to you. So this rectangular method I'm going to show you guys. So we're going to do it this. I don't know if I have enough space I probably should. So what this rectangular method is doing is, you probably have seen this before. This is probably one of those kind of new mathy things. So anytime you hear someone say, like, I don't like that new math, like maybe your parents or something, when you guys were little, you learned probably new math that, like, you know, I used to tell Mr. Donahue not to try to help the kids with math because it was new math and he didn't understand it.
Yeah, my parents yell at me like I choose.
Right. Well, so high school math typically is still the math, like, because obviously, like I told you guys, I've been teaching, you know, like my students are now probably as old as your parents, so I've always taught the same kind of math. It's not new math. This is the same math I learned. So what I do is I take these two terms and I put them over here. So 3a and 4. So 3a and positive 4. So I took those from that parenthesis there. Then the other terms are going to go on the top of my rectangle. If you hopefully have space, or if you have it on the bottom, it's fine.
Are we going to be forced to use this method?
No.
Because I really don't want to use it.
Okay, and that's fine. It's just, I think this is good maybe for some people that aren't as organized. Some of you guys are really great at keeping things organized. Others of you are not.
Oh, I'm
So,
not organized at all.
Well, with your work you are. Like, I have some organizational issues too, but with my homework and my math thinking, I definitely am organized. But so I multiply these two together. So I'm basically multiplying all of these. And so it's allowing you to make sure you distribute everything. You don't miss anything and you don't get them mixed up. So these two get multiplied, so this is 3a to the third, which is what we had up here, remember. So we're getting the same outcome, it's just another way to show it. Then I have to multiply this 3a times the negative 5a. So this is negative 15a squared. It's just another way to do the same exact math, it's just a different organizational method. So I'm multiplying in this rectangle.
I think this is making a lot more confusing.
That's fine, and you can decide that. Like,
Yeah,
there's.
this is very confusing.
Like I said, this is probably like one of the only like new mathy things. I kind of like the idea of, just because it keeps, some people just aren't organizational people.
I sort of get the point, it just doesn't really make sense.
Okay, so then once we're at this point, and like, yeah, take it or leave it when you guys are done here. So now you guys can see these two are the same and these two are the same. So I'm just going to combine them just like I did up here. So I'm adding a negative 15 and positive 4. That's how we get this negative 11. The positive 3a and negative 20. That's how I get the negative 17. So you get the same outcome. Obviously you should, because if we're using a different method, it better still work. But it's just another method. And it's up to you guys. I just wanted to show it to you guys because it is another method. Now in your homework, I think it says use, they call it like the box method or rectangular method. You do not need to. If it tells you to do that, you don't have to follow those directions. Or you can decide that you want to. And this does work for FOIL as well. You could use this a little 2x2 box. But it's up to you guys. Don't feel like you have to use it. So let's look at example 8 together. A couple more to do here. Example 9 we're not actually going to do, but we'll talk about it.
Oh, it's a little late now. I already started.
Oh, look at you. So if you like that box method for this or the rectangular method, you can feel free to do that. I'm going to probably stick to the FOIL based off of the feedback I'm getting from you, but if you like secretly are like wanting to do that method, I can always help you with it if needed. So, so example 8 here, we're distributing, but again, kind of using that modified FOIL. So this first term has to go to all 3 terms. So I'm multiplying to all 3 places. This one's kind of nice because the coefficients are just ones. So I did those first 3 terms. Now I'm going to do the next 3. And if you don't end up with 6 terms on this step, you probably missed something. So kind of just double checking, if I got 6, I'm good to go. Now I'm ready to combine my like terms. So if you notice, m to the third doesn't have any like terms, so I'm just going to write that first because that's the highest power. Those are like terms. 2m squared and 2m squared is going to be 4m squared. Remember, we're adding. And positive 1 and positive 4. And then just the plus 2 at the end. Okay. All right, so I want you guys to look at the, so that's number 9. Are you okay on those? I mean, just so you guys know, these are not like, these are less common than FOIL. So like the front side is more common to what we'll use a ton. These will happen, but there won't be like, you know, a ton of them like on a test or even in homework. So, okay, so yeah, let's talk about example 9 and 10. So what I did with examples 9 and 10 is the exact same problem, so I did one little change to them.
Which bag they gave me a struggle looking at 10.
What's that?
He gave me a struggle looking at 10. I'm like, that's the exact same, and then I see the plus.
Okay. Now, if you wanted to do 9, you could. If there's one like 9 in our homework, I'm going to cut it out. I'll just double check. But in number 9, this is like FOIL on steroids. We would have to multiply this times all 3. Then I would like switch colors because it's hard to see otherwise. This times all 3. But then there's still a whole nother term would have to be multiplied by all 3. Whoops, I did the wrong one. So this one would be a big mess. So it'd be 3 times 3, which would be 9 terms. I'm not going to give you any like that. So I'll double check on homework that there aren't any like that. So what I'm trying to compare that to, though, is number 10. They're the exact same. Yeah.
There's a plus sign.
There's a plus sign. So what does that do that's different? Why is this problem okay to do and the other one's not? What's different about it? What are you going to do here? Do you have to FOIL here? No, this is like yesterday's homework. This is just addition. So be careful that every time you see a bunch of parentheses, that doesn't mean to multiply. If there's nothing between them, that's when we multiply. Here, this is telling us to add. So this is just combine like terms. Now, it won't tell you the difference. They should, like, they're expecting you see that plus sign, and you're like, sweet, I get to add. Versus the one above, yikes, I have to multiply all those terms together. So in this case, this is combined like terms. I technically distributed 1, but I don't really need to. So I have the x squared and the 3x squared. How many x squareds is that?
2 or 4, sorry.
It's opposite day. All right. And then we have 2x and a negative 5x, a negative 3x, and then negative 2 and positive 1, negative 1. So be careful. Now that we've learned FOIL, I feel like every time a student sees parentheses, they're multiplying everything together. If there's a plus sign in it or a minus sign or a problem like the warm-up, just remember these aren't all automatically going to be multiplication. So make sure you guys are double checking on that. Let me just double check on our homework that I didn't give you any of the 3 times 3 because those are brutal. Yeah? Yeah, give me a second. No, they didn't put any 3 times 3 in there. I don't think. 35. No. And so you don't have to follow the directions. Basically, you're just simplifying all of these. Okay? So you guys have the rest of the time to get working. We do not have, we have ACP today. So just so you guys know that it's one of those Zello lessons. So just that you guys know So this is what's due for tomorrow. So 3 through 35 odds. It's about 16, 17 questions.
No. It's wonderful. So weird about that.
What's up? I think you are good. I didn't have it on my notes. I'm sure I'd done it in years past, but looks good.